Hello everyone, welcome back to my RAG lecture series. In the last class, we have discussed what is a RAG, what is the purpose of RAG, how RAG improved the performance LLM. Because LLM have so much of knowledge because it is trained on the public data, lot of public data. But the problem is companies won't give their public data, give their private data into the public domain. No company will interest to give their own private data publicly. So that when we are training the large language models, we can use only the publicly available data, but not the private data of the private policies of a firm or an organization. Suppose if an organization wants to make use of LLM, wants to leverage LLM, and they want to work on their private data, they need the RAG help. That is where the RAG helps the LLM to improve the efficiency and the response from the LLM. I already explained in the previous class. LLM has a big problem that we cannot train the LLM frequently on day-to-day basis or on monthly basis. So LLM's knowledge is always old knowledge. So now if we ask a question or if you ask a prompt to an LLM, even though it has no updated information till now, till date, it tries to give some answer with its previous experience, with its memory. So there we may not get the exact response, incorrect response. So that's why we will call it as an hallucination. Hallucination means even though it doesn't know anything, it doesn't have the proper exact information about the prompt, it tries to give some information, it tries to answer, it tries to respond, it tries to respond to the prompt with its previous knowledge. That response may be correct or may not be correct. So in order to improve the efficiency of the response, in order to use LLM in your private data, in your private policy, we need the RAG architectures. So that is where in the last class I have explained you briefly about why RAG, what are the advantages of RAG, where the lagging of LLMs are there, where the failure of LLMs is there. How can we come across, overcome those failures from the LLMs with the help of RAG. So today also in this session, in this video, I'll continue the RAG internal details and how the data pipeline, what is an ingestion, how we are collecting the data, how that we are chunking the data, and finally we are embedding and we are transferring the data into vector databases. So here I'm going to explain you more clearly about the RAG from starting to the ending. Here, artificial intelligence is changing the way we search, we learn, we work, and build software. So we cannot say that artificial intelligence is here or there. In many fields, in many ways, the artificial intelligence is transforming. Suppose here we can write just AI is changing the way we search, learn, work, and build software. It is changing the way how we are searching, how we are learning, how we are working, how we are building the software. So in this, one of the most important AI concept is retrieval augmented generation. So as I explained in the previous class, first of all, we are collecting data from different sources. It may be Word documents, it may be source of data, it may be Word files, or it may be documents, or it may be any kind of files we are gathering. We are gathering like the data may be PDFs, the data may be websites, the data from websites, DBs, databases, Word files, different APIs, CSV files, or company or any enterprise internal documents. So these are all source of data. So now what we are doing? We are bringing the data and we are chunking. That means we are dividing data into small pieces. Then by using a proper embedding technique, we are converting data into vectors, numerical vectors. Then we are storing these vectors into a vector database. Here, the name itself is there. This is a vector database. It is storing the vectors. What is a vector? Vector means a set of numerical values. Each chunk is converted into a vector. So what is there in the vector? Numerical values are there. So now those numerical values vector will be stored in the vector database. Now user has a query. User has a query. User came with a query, or you can call it as a prompt. Now, according to the query, this query will be again embedded or converted into embedding vector. That means whatever the technique which we are using here to embed the sentence, the same technique will be used to convert into vector. That means our query is converting into embedding vector. Our query is embedded. Now this vector we are comparing with the vectors in the database by using similarity searching techniques. Those vectors which are similar, which are near to our prompt vector, those will be the top K searches or context vector or similar context vectors will be taken out. This context plus our query plus our query will be combinedly sent to LLM. Now this LLM with its memory, with its knowledge, it checks your query and accordingly it answers from the given context. And finally, it is giving the response. So this is what happening in the RAG. So here, this is what we are bringing the required context. This is what is called as retrieval. This is called as retrieval phase. And this we are, the context and your query, we are combining. This is called as augmented phase. And finally, we are giving and we are getting responses. So this means RAG means retrieval augmented generation. Now this LLM is generating the correct response from this context and the query. So this is what actually happening in the RAG architecture. If you see the architecture, you can see here we are collecting the data. Here we are collecting the data and we are chunking the data. That means PC, we are splitting the data into small pieces. Why? Because the LLM context window has some fixed size. LLM context window has fixed size. So we should not give thousands of words. So that's why we are chunking. That means we are dividing the entire document into pieces. And we are each piece converting into vector. That means your text is converting into vector. Now these vectors are stored in vector database for similarity search. For similarity search with user prompt. With user prompt. Now user has given the query. Now this query is converted into embedded query. Now this embedded query is compared. That means it is searching according to the query. It is searching the related context or related information from the knowledge base. From the knowledge base. What is this knowledge base? Vector database. Vector DB. Vector database. So here the topmost similar K chunks will be retrieved. Now these retrieved information, retrieved context plus your prompt. Here you can see your context and your question will be a prompt to the LLM. So LLM will generate answers based on your prompt and the context. Now it is giving the grounded actual answer and from where it is getting and it is also giving the citation of the answer. So these are the sources from where I got this answer. I got this response. So this is the complete end-to-end information about RAG. Here if you can see the injection. So here this is injection phase. Here in this injection, these are all your sources. These are all sources. These sources we are converting into pieces. That is called as chunks. We are converting into chunks. Then every chunk is converted into embedding vector. That means numerical vectors. Now this embedded vectors are stored into vector database with some index. So that with the help of index, we are going to retrieve the required context vectors. So this is what is called as ingestion. Now if you see how a text is converting into a vector. Your text is converting into vector. You can see your text is converting into numbers. Suppose if we see, let us suppose we have three chunks, chunk A, chunk B and chunk B. Let us suppose there are three chunks with three sentences. The dog chased the ball. The second sentence is a puppy played fetch. And third one is stock prices went up. Now we have converted all these sentences using auto encoding LLM. Now, so for the first sentence, let us suppose these are the vector. So you can see the vector is converted into numerical values. Here this sentence is converted into numerical values. Now if we compare these three, you can see there is a close values from vector A to vector B. Vector C is nowhere related to A and B. Now we can see that these two vectors are similar to each other. Similar to each other. We have so many similarity techniques like cosine similarity, Euclidean distance. By using any measure, we will check the similarity and we will retrieve the top k similar chunks related to our prompt. So this is what happening in vector embedding. Now you can see a very clear diagram here. So this is data source. You are converting your data into chunks, small pieces. Now every chunk is embedded. All these embedded vectors are stored in database. Now this is your prompt. You are finding the relevant data from the vector database. Now that context and your prompt you are giving to the LLM. Now this LLM is generating the response. So that this response is reliable compared to the LLM's own decision. Here LLM is not only dependent on internal memory. Here LLM is not only depends upon its internal memory. It depends upon the external sources. External sources. So now it is using its internal memory and external context according to the prompt, so that it is generating the response, so that we can believe the possibility, the quality of a response. So this is what happening in RAG. So now I'll explain what is the chunking process. So where we collect, so suppose if you write the basic workflow of RAG, basic RAG flow, First what is happening? User question, or you can call it as a prompt, user question. Now what is the next step? Retriever searches. Retriever searches documents. What documents? Related documents. Now relevant chunks received, or you can call it as retrieved. Relevant chunks retrieved. Then our context, the context plus the question, or you can call it as a prompt. Question we are sent to LLM. Now final response from LLM. This is what is called as AI generated answer. This is AI generated answer. So this is the basic workflow of RAG. In this workflow, suppose what is step-by-step workflow? First of all, step one is data collection. So you are collecting the data from where? We are collecting the data from PDFs. We are collecting the data from websites. We are collecting data from databases. We are collecting data from Word files, APIs, CSV files, organization, internal documents. So these are the sources of information, sources of data. This is the first step in a RAG workflow. So after collecting, what we need to do? After collecting, step 2. Chunking. After collecting the data, documents, we have to chunk the documents. That means large documents are split into smaller chunks. Suppose example. Suppose I have a 100 page PDF. I cannot give 100-page PDF as a single prompt to LLM. So that what should I do? I am dividing this 100-page PDF into smaller paragraphs. Why? Why we need to do? Because our LLMs and vector databases works better with small meaningful text pieces. Our vector databases work better with the smaller meaningful text pieces. That means what you need to understand here, we cannot give the hundreds of pages or words into our LLM, or we cannot store directly the 100 pages of PDF into databases, vector database. We have to divide into small pieces, then only we can convert into a comfortable embedding, and so that we can store comfortably in vector database. So what is chunking? We are saying that we have to divide the data source, the PDF, into pieces. So what is meant by piece? Piece means chunky. Here, if you know what is chunking. What is chunking? Chunking means dividing. Suppose if you see the definition of chunking, chunking means dividing large text into smaller pieces. That is what is called as chunk. Suppose if you see our PDF example, we have a 100-page PDF. Then we are dividing into paragraph 1, paragraph 2. Like that, we are dividing our text document. So in the market, in the present day, there are different chunking techniques are available. Different chunking methods are available. So out of the most famous methods are fixed size chunking. Second one is sentence based chunking. And third one is semantic searching, semantic chunking, and finally, recursive chunking. There are so many chunking techniques are there. Out of the most important chunking techniques are fixed size chunking, sentence based chunking, and semantic chunking, and recursive chunking. So I'll take a special complete video on the chunking methods, how the chunking will happen with these methods, and which chunking method we need to take in at what context. All these things I will clearly explain you in a separate video. So after chunking, so what is happening? We are going for embedding each chunk. We are going for embed. That is, we can call it as a step 3. Step 3. Embeddings. So here text is, what will be embedding? Text is converted into numerical vector called embeddings. Text is converted into numerical vectors called as embedding. This is happening in step 2. So these value embedding means numerical values. These values as a human we may not be understand, but as a AI it has some understandable meaning. These vectors you can write like this. These vectors help AI understanding meaning. Understand meaning. So as a human, we may not understand anything from these vectors, but as a AI, it can understand what is there with those numerical values. Why embed? Embed helps for semantic search, for similarity matching. If you want to compare which sentences are similar, which words are similar, then embedding will be helpful for. So why embedding matters? Why embedding important? Why embedding is important means means one is one is semantic search. Semantic search. We can set the meaningful sentences and we can check the similarity matching. We can check the similarity matching and we can do intelligent retrieval. We can do intelligent retrieval. That means according to the prompt, we can retrieve the correct exact context from the given vector database. So embedding helps us to search semantic search, similarity matchings, and intelligent retrieval. So this is the advantage of embedding. And finally, next one is step 4. We are storing all these embedded vectors stored in vector DB, vector database. So if you see in the market, there are so many popular vector databases are there. Vector databases. Out of those, the first one is Pinecone vector database, ChromeDB, VV8, PICE, ficus, milvus, quadrant. These are the famous vector databases. So while I'm explaining with real-time application and in terms of programming, I will explain each of these vector databases in our practical. So only the reason for vector database is it is very easy to search the similar vectors. So vector database stores embeddings and performs similarity searches. So instead of searching the keywords, we are searching the meaningful vectors. It finds meaning based on the matches. That is what vector database. In traditional searches, we will match the keyword. But in vector search, we are matching the meaning. So that means what is happening? A simple sentence for vector search. Vector search. Meaning matching. Here we are matching the meaning rather than the exact word. So this is what we are doing with vectors. Vector DB. And step 5. Step 5. Retrieval. So whatever the user query is there, query becomes, we are converting the query into, user has a query. We are converting the query into embedding vector. Now your vector database, now you are checking in this query, we are checking in the vector DB. We are checking this query in the vector DB. That means vector DB searches similar chunks. Now the similar chunks are retrieved. Relevant similar chunks retrieved. This is what is called as, this way of searching is called as semantic retrieval. And next sixth step is augmentation. What is mean by augmentation? Query plus your retrieved chunks. Whatever the context you have retrieved, both we are combining. That means query plus retrieval information or retrieved information. So what are we doing? We are sending to the LLM. Seventh. So we are sending this one to the LLM. So now finally LLM generates the response to the user prompt, or you can think of user context. So this is what what is happening from end to end in RAG. So when we need to use RAG, so when we use RAG is when data changes frequently. Suppose when we need to use RAG, when to use RAG, when data changes frequently. If the data is changing frequently, we cannot train or we cannot fine tune LLMs frequently. So that we have to come for RAG. When you need latest information. This information may not be available with the LLM. So that we need to go with RAG. So when you want to do some application with, when you want to use your LLM in company's document, when you want to apply your LLM on company information, then you have to company documents, then you have to go with LLMs. And if you want to build enterprise chatbots with the help of LLMs, then you have to you have to take the help of RAG. When you need best explainable answers in real time with live data, then you have to go with answers. So these are the things, these are the situation where you need to utilize, you need to take the help of RAG. So when you see the real world cases of RAG, suppose last 5 minutes I am taking the real world use case of RAG. Suppose if you take real world use cases, real world if you take the real world use cases of RAG, first one is customer support chatbots. There you can use RAG happily. Customer support chatbots. And if you want to use RAG, you can use in healthcare systems. And we can use RAG in legal AI assistance. We can use the legal documents where you can use, you can leverage the help of RAG into legal systems. And you can use RAG in educational platforms. And you can use RAG in enterprise search. We will do so many applications by using RAG in upcoming videos. And you can use RAG in banking and finance. So these are the places where we can use RAG. So the best practice of RAG, the best we can get most benefit from the RAG if you take the good chunking, if you store embeddings perfectly, and if you use hybrid search, then we can take the best outputs of the RAG by helping the LLMs in the LLM world. So this is about the complete concept from gathering the data sources and till how an LLM is able to answer, will able to give the correct response for the user prompt by using the vector databases and with the help of augmented retrieval generation. So I hope you understand what is a RAG. I take 2 classes to explain clearly the concept of the RAG from beginning, how to gather the data, and finally what is happening in the RAG. And also I gave some real-time examples where we can use the RAG. So in the next class, I will take an example, live example, and I will show you how we can do the RAG application with the coding and some AI tools and very apt APIs so that you will understand the real application of the RAG. So don't think that my videos are long. I am always try to give a clear concept so that you should never forget and you should be able to answer in the interview perfectly. There is no shortcut for learning the quality information or quality lecture. So if you want to learn more, definitely my videos will be longer. You have to be patient and please listen carefully so that definitely you'll understand so many things so that you can easily answer the interviewer. So don't think that always these classes will be in a theoretical manner. So here just I have given the foundation of that. In the next classes, I will explain with an example with code with real-time application. So please watch my video. Thank you. Thank you for watching my video.